Now, there is another assumption. It's a little bit more subtle, but if you think about your programming experience, it will make it more concrete. It's the assumption that these mechanisms, not only they are reusable, but they are algorithmically independent. So what does that mean, algorithmic independence? It's a little bit different from the usual statistical independence. To understand what algorithmic independence means, imagine that each of these mechanisms was described by a piece of code, right? Software. And that you were to compress that code, gzip it. Then algorithmic independence, perfect algorithmic independence, would mean that there is no advantage in terms of compression length. By compressing two of these mechanisms together versus compressing them separately, and then, of course, how much length do I get by adding the length of the compressed first one plus the length of the compressed second one. So if there is no advantage, that means they have nothing in common, and they are kind of independent in this algorithmic sense. All right, so why is that interesting? Well, first of all, notice that this is how we try to design software. When we design software, we try to break it into pieces such that if one of the other pieces or several of the other pieces were to change, the existing pieces continue to function properly. Okay? Like bad software is software like if I change one of the functions, one of the classes, one of the modules, everything needs to be rewritten. You don't want that, right? But you can see how this would be advantageous from a machine learning perspective, because if I have to revise one of my pieces of knowledge, or if something changes in the world that changes the way this mechanism works, like the constant of gravity changes. If I only need to adapt my model of this mechanism in the world, and I don't need to change the parameters of all of the other mechanisms, then I don't need as much data to adapt to those changes. So clearly, this would be a great advantage for out of distribution generalization and out of distribution adaptation.